Welcome to Talking Architecture and Design. My name is Branko Miletic, and today we have with us two guests, one in Sydney and one all the way in some place called Tasmania. Stuart Brain is the National Specification Manager for Kingspan Insulation. He has over 20 years of experience in the building materials industry. He spent 10 years in the plumbing industry before transitioning to work for a variety of building material manufacturers. His experience in the plumbing industry gave him a deep, no pun intended, understanding of construction process and the importance of quality materials. Stuart holds a Bachelor of Science in Chemistry, which provides him with strong technical skills, and an MBA, which helps him with business skills. Then we also have with us Brent Livy. He is the National Residential Sales Manager for Kingspan Insulation. He has over 12 years of experience in the building materials industry. Prior to Kingspan, Brent worked for James Hardie and Miele Appliances before coming over to Kingspan. His experience working with global building material manufacturers has given him a broad understanding of competitive landscapes, challenging market conditions, and the importance of quality products and customer excellence. Brent's also completed an MBA, which has helped him his understanding in the business operations of the company. So welcome to Talking Architecture and Design, Stuart Brain and Brent.
Thank you. Thank you. Good to be here.
Thank you. Good to be here.
Okay, I'm not going to allocate questions to anyone. I'm just going to throw it out to the crowd, as they say. Best in, best dressed, as they say. What a complete answer. So, tell me about the Kingspan story, comprehensively, yet briefly.
Yes, Stuart might take the first one off your hands. Kingspan's actually a really interesting story. Kingspan was founded by Eugene Mertag in Ireland back in 1965. They were actually had a family pub, and at the back of the family pub there, Eugene actually started a small engineering and contracting business, and the business was actually called King's Court, which is where their family pub was originated. From there, they began manufacturing agricultural trailers and then expanded into pre-engineered wall panels. And then from there, moved into more insulated panels and the likes. So over the years, the business has grown purely by acquisition more than anything else. It's a very large business now, from being acquired many businesses across the globe. So we're currently sitting at 212 manufacturing sites globally over 80 plus countries, and at 22,000 employees. So it's a really good success story from a family-owned pub, and with Eugene actually stepping into a completely new industry and starting it from scratch. So really, really good story, and a huge business which is listed as well.
That's really interesting. So the pub wasn't busy enough in Ireland, so they had to get into insulation. There's a longer story in that. I was going to say that Ireland not exactly known for its heat, so I'm assuming that would be insulation for cold, right?
Yeah, totally. That's exactly it. So you need to insulate buildings in summer and winter. So typically, we're talking about, if you talk insulation, we're talking about heat movement. People say, the cold came into my house. It's not that at all. It's the heat that's lost, right? So, typically as a base rule, insulation just stops movement of heat through buildings. That's all it does. Now, thermal insulation, because you've got acoustic and other types of insulation, but we're talking thermal insulation. And for example, if you in summer in Queensland, you don't want the heat to come in the house, but in winter in Melbourne, you don't want to lose the heat in the house. So it's the opposite, isn't it? But it doesn't matter what it is. It's whether the heat's coming in or whether the heat's going out of the house or building, depending on whatever it is. That's what insulation does, and that's what Kingspan's products do best they can. And you're never going to stop it. It doesn't stop it at all. Nothing does.
Yeah.
It's just minimizing that heat transfer between building elements, whatever your building's built of.
In your opinion, what is the best type of insulation material? Like if you were building a
Yeah.
house, say, what would be the material that you would go to? Considering you guys are experts, yeah.
Yep. I'll just take a step back though, because it's really interesting what you just said. So 20 years ago or more, there was no requirement for insulation.
True.
And you might remember when you were a kid on Dad's house, when it was hot in summer, it was hot inside, and when it was cold in winter, it was cold inside. And since all those times, the building code, whether it's a class 2, class 1 residential through to all the other commercial codes, those classes, we've improved the requirements for energy consumption for buildings. And ultimately, that's what it comes down to. So, nowadays we have to insulate buildings and we have to let them breathe. And Brand will talk about that in a little while. But, what that means, excuse me, what that means is it brings up other problems in the building. If you're going to insulate a building and you're going to make it airtight, there's other problems that can come from that. But to answer your question, the best type of insulation material, it really depends. It depends on, because you want, it's like anything. It's like what's the best car for someone to drive?
Yeah. Okay.
Well, is it a guy who's single and wants just a fast car, looks cool, or is it a family with 3 kids, that wants a lot of room with all the different, luggage compartments and car seats. So, it's not a one size fits all in any stretch, but you want high performing where you can. You want it to be high performing, and you want it to be do its job. And it just depends on what the building's made of, and it depends on the class and what the function. It's a big part of the code now is the function of the building. So,
right.
We use an example in Kingspan. For example, if I built my house and suddenly turned it into a commercial laundromat with dryers, and you'd have a lot of moisture and a lot of vapor within your building. You'll have mold problems. You have condensation. You'll have things rotting because it wasn't designed. It wasn't built that way to accommodate a commercial laundry. It was only built to house 3 people. So depends on what type of building it is and what your function is, I think.
Interesting. In practical terms, what is the difference between reflective insulation, thermoset insulation, air cell insulation, and, of course, insulated plasterboard?
Yep. Good question. Thermoset insulation. So take it back, for example, everyone knows what glass wool is. A term called glass wool, bats, blanket. They're the fluffy glass made woven product that sits in your walls and sits in your roof that everyone's familiar with. There's a new range of insulation called rigid insulation. And for those who aren't familiar with it, if you can imagine, when you get your pot of plants from the florist and they put the stem of the rose stem into the little spongy stuff in the bottom of your vase, there's insulation that's got a similar consistency to that.
Right.
Right. And it's rigid. It's not flexible. It's not there. So, and thermoset insulation means, in the event of a fire, it behaves really well. Okay. So thermal compliance on buildings is as important as fire compliance. Right. So we want to make things, albeit really good thermally, we also want to make them pretty good in the event of a fire. We don't want them to produce smoke. We don't want them to melt and drip, right, and be a pool of fire, because it's bad for the residents, of course, bad for the fire brigade. You've got to come and put the building out. A thermoset insulation doesn't do that, and that's what Kingspan Cool Therm does. It's a material that, in the event of fire, it doesn't melt and drip and smoke. It's really good material. Now, reflective insulation is if you put a layer of reflective foil on it. You might have seen some insulation in your roof. It's got reflective foil, like silver foil on it.
Mm-hmm.
The reflective foil adds an additional level of insulation to the existing glass wool or rigid or whatever it is. It adds more R value. It adds more resistance, more insulation to just by the fact that it's a reflective surface creates insulation. Air cell is another range of cool therm. So it's a polyethylene product that's thin, used for thermal breaks, used for in a lot of the sheds that you see around the place have used air cell and insulated plasterboard. So there's products coming out now that are rigid, and you can imagine your walls, for example, or your ceiling where you've got plasterboard on the wall or on the ceiling, and directly behind that you would have insulation. Well, what we do now is we manufacture rigid insulation, and we have plasterboard already bonded to it. Okay, so what you're getting is your plaster and your insulation in one go. It's what they call insulated plasterboard, effectively. So and where it's used really cool is if you've got an existing house and you don't want to pull all the existing plasterboard off, or say it's asbestos, you just want to upgrade what they call the thermal shell. You can just pull your skirting off, your cornice, your door frames, and you can fix this insulated plasterboard straight to the existing wall or the existing ceiling. And instantly you've lost about 50 mil thereabouts, because that's all you need, and you've got a really well insulated building from there going forward. So, like I said earlier, we're just stopping heat moving through building elements. And building elements, I'll just take walls, for example. Now, if we're stopping heat moving through, it's got to stop the heat moving through concrete, through steel, through plaster, through air, right? And we're trying to not stop it. We're trying to minimize it, okay? What insulation does is there's things that have different levels of conductivity. So if you can imagine heating a piece of steel up to, 1,000 degrees, if you touch it, you'll get burnt. If you heat insulation up to 1,000 degrees, you touch it, you're not going to get burnt, because it won't allow the heat to transfer through that material. In other words, a low conductor of heat.
Right.
So things that have got low conductivity are really good insulators. Things that have got high conductivity, like steel, like even concrete, even anything with rock, like blockwork, brickwork, clay, all that has got reasonably high conductivity, and therefore allow heat to transfer through. In other words, energy. So air is still air, believe it or not, is a good insulator. So if you've got a cavity in your wall, so typically, something like a 50 mil cavity, that'll give you a reasonable level of R value, because R value is the level of resistance required, and that's what stops heat, and it resists the movement of heat. And heat is all about transfer of energy, okay? Because heat is energy. Right. So, if we're going to stop heat, we're actually stopping atoms and electrons, and the energy of those moving through, passing on the energy through different materials, right? So Kingspan Cool Therm, which is a rigid insulation, is a product that it's foamed. In other words, if everyone knows what Aerobar, the chocolate Aerobar has got bubbles in it, okay? The Kingspan Cool Therm rigid insulation is exactly the same as that, albeit the bubbles are 1,000 times smaller. The phenolic resin, or the phenolic board, holds in the bubble what is a gas in the bubble that has very low conductivity, right? So the Aerobar is the chocolate. It's what's in the bubble that stops the heat transfer because of the conductivity level is so low. If that makes sense.
It does make sense. Stuart, the other thing I'm a bit disappointed about, you didn't actually even go into the electrons. That was an electron flow, but we'll get to that next time. Look, you
explain that for us, Stu.
I was waiting for Brent to jump in on the electron side of it.
Another session for that one.
I was going to say, you mentioned R value. So that's actually important, because that's actually misunderstood, right? And there is a range of R values depending on the material, obviously. So yeah, masonry has an R value. I mean, my house is made from something known as timbercrete, so the R value is fairly high. But can you please explain what is an R value? What are some typical R values? And what is there such thing as the perfect R value?
Yep. R value. So everything measures. Well, in Australia, there's lots of different values. There's R, there's U, and there's K values, and I'm not going to go into those, but just for simplicity, in Australia, we talk a lot about R values, which R stands for resistance.
Right.
Okay, so again, the resistance of movement of heat through anything. So the higher the R value, the better the insulation. So all materials have a declared R value.
Right.
Okay, all materials, even I'm looking at my notepad on my desk, would have an R value. Your pen in your hand, me standing here, like just air. Like I said, still air has an R value. Okay. So when we're talking about R values, we're not just thinking about the insulation product. We need to take into consideration all the building elements: plasterboard, sarking, air, steel, timber, concrete. Everything has R value. So typically what happens is energy consultants on commercial jobs, and depending on the states, it's measured differently, but they'll say, look, as a rule, you might have an R 2.5 for the wall. Okay. That's what we need to hit. And you might say, okay, the timber, the steel, the air, the sarking, the insulation, whatever else is in there, your weatherboard, your cladding on the outside, whatever it is, all contribute to R value. And whatever you're missing, well, that's what the insulation has to cover. Okay. So you might have everything else might give you R 0.5. So therefore, we need to put an extra R2 in the wall to bring the wall up to an R 2.5. Okay. Ceiling, you lose a lot of heat in the ceiling, and you lose a lot of heat in the floor. People don't think you lose a lot of heat in the floor, but you do. Ceiling in particular. So ceilings are typically, you could be R3 and above. Cold climates and high performing places, alpine areas, you're looking at R5s and 6s and so on.
Wow.
Yeah. So again, the higher the R value, the better. This means we're increasing the resistance of the heat through the wall. And there's no perfect R value. I mean, in for example, in Queensland, you want, because it's a hot environment, the climate zones, there's things called climate zones. So in Queensland, you've got climate zones that are, in 2 and 3. So you want the heat to stay out. So you don't want to. And one way you can do that with slab on ground is allow the heat to escape into the soil. So insulating the soil is probably not a good idea. But you don't want to necessarily retain the heat in the house because of the climate zone. So it depends on the climate zone. So there's no ideal R value. To be different in climate zone 6, 7, and 8, where it's colder and they'll need insulation in the floor and so on.
Particularly here in Tasmania, there's many homes here that insulate their floors, whether that's underneath the concrete slab itself or under the floorboards. So there's quite a few different ways of doing that, but it's certainly a strong focus in climate zones, particularly in Tasmania.
Okay, I'm still wanting to unpack that. So you're measuring resistance as opposed to conductance, right? So you're
Yep.
measuring, and that number that you get, let's say 4. Okay, for what? Is it a time based figure that you're getting, or what is that for actually encapsulate? Or 2.5 or whatever.
It's the number is, it's a measure of heat transfer. So what we do is we get a thing called lambda. So what we do is we measure the conductivity of a product in a laboratory. Yep. And how conductive it is. And then what we do is we get the thickness of the material. So we've got, say you've got a 100 mil thick product. You divide it by this thing called lambda, and it spits out a number, right? And that's the R value. It's a measure of conductivity, but then the conductivity will increase depending on the thickness, won't it? So a thinner material with a set conductivity will have less R value, will be more conductive than something that's a thick product. So in other words, insulation, like I said, the thicker the product, the more R value. So what we do, like, again, we just measure the conductivity, and then from there we've got a baseline, and we can just work out the R value based on its thickness by putting the thickness divided by its K value. It's lambda. So the lower the lambda, the better. They call it lambda in insulation world.
Right.
And everything's got a lambda.
Kingspan Insulation is a global leader in insulation and building envelope solutions. Kingspan Insulation focuses on innovation that makes a difference to you, offering high-performance, rigid insulation, ultra-thin flexible insulation, and building wraps. For more information, go to www.kingspaninsulation.com.au. And now it's back to our podcast. As you mentioned, Brent, Tasmania is different to, or different type of insulation or R value than you wouldn't say in far north Queensland or maybe even the back of the Pilbara. That's the benefits. What I'm trying to say is the benefits of insulation. It's not just obviously comfort at home. It's also cost savings, isn't it?
Yeah.
And then that does vary across Australia. Like, is there as a company, like, do you guys have some sort of figures that show, or I guess trends that show the difference between having an insulated home and a non-insulated home?
Yeah, it's a really difficult question to answer because there's so many different factors that come into play. Obviously, the climate zones that you're in, the materials that are used in the home to build it, even which direction the home is facing, whether it's north, south, east, or west, how many windows. There's so many different factors, but from a general point of view, you can even save up to 45% on your bills per year just on insulating a home. A fully insulated home compared to a non-insulated home can reduce the cost of heating and cooling to that amount, and which is quite significant. I guess in some cases we look at it as a general rule and say if you insulate your ceiling, it can be up to 20% saving. If you insulate the walls, it's around the same number, and floors is around 5 to 10%. So it is obviously quite important when you do insulate a home that it is done properly with the right products, which is in line with the area that you're living in, and doing it across all the wall, ceiling, and floor. Look, it's a difficult answer to provide, but from a general point of view, it's a significant saving for people to insulate their homes, and can pay for itself. As short as 5 or 6 years of investing into insulating homes.
And just adding that too, because what you mentioned is indoor comfort. So we did some work with one of the local universities in Sydney, who did a study around comfort for education, so for students. And it makes sense, but we didn't want to have the data. I can't remember the actual numbers, but effectively, making a building more comfortable to reside in, whether you're a student, whether you're a homeowner, whether you're a patient, a doctor, an office worker, a prisoner, right? It doesn't matter the building. Whatever you're trying to achieve improves. So if you're a student, you're going to learn better. If you're a teacher, you're going to teach better. If you're a doctor, you're making better decisions. If you're a patient, you're going to improve, you recover better. The indoor comfort's super, super important. And insulation is, what we're doing is evening out fluctuations in the environment on a hot day or a cold day, wet day, dry day. It doesn't matter, day or night. Yeah. We're saying inside's going to be constant and nice and comfortable for whoever's in that building. Okay.
And that's a really good point, Stuart. Even in our manufacturing and plant in our head office in Somerton, Victoria, it's a 6-star Green Star building. It's obviously insulated really well with Kingspan products, and the environment where we work is really comfortable, no matter what time of day. and the conditions outside, it's a very stable climate, and we even find it a lot more comfortable to work in our office than it is in others. It's a dramatic difference between our office and others that aren't as insulated.
Yep. And also, I mean, Brent knows about it more. Everyone woken up one morning and you've got up and there's condensation on the inside of your window.
Yep.
I think everyone has seen that.
Yep.
That's as we live in buildings and we wash clothes and we cook and we clean and we do our thing and have showers, we're creating what they call vapor in the air, right? So it means that there's actually water that you can't see in the air. So it's actually an increase in relative humidity in that building. That's got to get out. You can't leave that in the building. And the fact that you've got part of your wall or your ceiling that's not insulated, that's where the vapor accumulates on the wall or the window. And when you wake up in the morning, that's just you're breathing through the night, and you're losing moisture, and the vapor that's in there or the water droplets accumulate on the window. Why do they do that? Because it's cold. So inside's warm, the window's cold, it's hitting that cold surface, and it's starting to get condensation. Condensation, if you don't deal with that, and it doesn't have to be condensation that you can see, it can be in the wall, it can be in the roof, it can be if your building isn't designed and developed correctly and built properly, that can be inside places you can't see. And what happens then? You get mold, you have rotting structure, you get mold spores. It's a really unhealthy place to be, right? And you've got to get people in to address that. They can clean it, but in a year's time or even less, it'll be back. Okay, it's treating the headache, not the virus sort of thing. If you know what I mean. So yeah, it's a
really good point, Stu. For a family of four, it actually for a family of four in a household, you actually release up to 20 liters of condensation every single day from showers, cooking, and just breathing and having humans in a house. So you can imagine 20 liters of water or condensation trying to escape your house. And as Stu said, it's got to escape somewhere. So that's why you see that condensation on the windows, because it's trying to find the coldest place on the wall to escape, and all that condensation is basically going straight through your plasterboard, through your insulation, and it just sits in that wall cavity. So it's obviously really important for that to escape, and that's why we have a permeable, breathable membrane to be used to help manage that condensation and avoid the risk of health issues, and both human health and the health of the structural wall as well. So it plays a massive part in improving, particularly people's health around, breathing and all of that, with anyone that has any of those issues around asthma. So it's a big space that the construction code is focusing on, to ensure that the new builds moving forward can protect on both human health and the health of the actual building itself.
And we never had this 30 years ago. There was never problems with mold, and it might have been in some cases, but largely because we didn't insulate buildings.
Yeah.
And we didn't have high performance glazing. We never had this. So we weren't trapping vapor in buildings. We were never doing that. So it could just escape, just like heat can, and you find that colder climates have more issues with mold and condensation escaping. We'll have than warmer climates, because the colder climates are, they're quite often insulated quite well, and they're sealing up their buildings really well because they need to keep the heat in the building. Okay. And therefore they're keeping the vapor in as well. And they haven't allowed for any mechanical systems or, and like Brent said, any vapor permeable membranes that allow this vapor to escape. So they didn't.
And it's important to know the difference between, and we've all seen, for those that are listening that haven't had a lot of experience in this industry, we've all seen houses being built, and you see, a blue foil being wrapped around a residential house, and that's always been around for a while, and you always see it, and you wonder what it actually does. And in some climates, it doesn't do much at all, to be honest. And that's really the big difference that we've got at the moment, is that, the blue foil being wrapped around a residential house, and you that's always been around for a while, and you always see it, and in some climates it doesn't do much at all, to be honest. And that's really the big difference that we've got at the moment, is that we're changing in certain climates, in climate zones 6, 7, and 8, in Victoria, Tasmania, ACT. That's where the requirement of using a breathable wrap over a foil wrap is beneficial, so it can manage the condensation. When you start using a foil in those colder climates, the condensation just goes through the plasterboard, through the insulation, hits the foil, and just drips down into that wall cavity, causing mold, mildew, and structural damage as well. So that's the importance of the difference between using a cheap foil in cold climates and a breathable foil that allows the condensation to escape the wall cavity. So that's really, really important for people to know the difference between those two different products in different climate zones.
Well, you both mentioned floors. So why do floors need insulation? Well, why do some floors need more insulation than others is probably the question I'm trying to answer.
Everyone's got this myth, not everyone, people who are not in our industry, I suppose. It's an assumption that heat rises, like the heat out of a coffee cup, and you can see the steam rising up. But actually, in factual fact, there's a lot of heat that's lost through the floor. And in simple terms, when you don't want to lose heat, because in the warmer climates, you actually want to lose. You want heat to remove heat from the building, and therefore you've got different designs. But let's just talk about the buildings that you want to retain the heat in the building. The colder climates, then you need to insulate under your floor. Now, floor could be, you could have a subfloor. In other words, you've got room under your floor itself. So you've got a subfloor. It could be concrete, it could be timber. Really important you insulate that. If you've got a floor that's sitting on earth, slab on ground, for example, insulate that as well. Really important. And then also insulate the edges of your slab as well. There's different materials that do that, but effectively, it's no different. So when we talk the building envelope, we call building envelopes a term that we use. Includes floor. Doesn't include roof and walls only. It includes the floor, and it's as critical that you assess that as part of your envelope, just like you're assessing the wall, and just like you're assessing the roof.
There are a range of new building code changes coming through insulation. What are they, and how do you think they will impact architects and designers?
Yep. So Brent mentioned some code changes a moment ago. So the NCC, or National Construction Code, so every few years they bring out a revision of the NCC. So the NCC 2019, that came out, and there was some, for those who are not across the code as much, there's sections of the code. So you've got A, B, C, D, and so on. So section J in NCC 2019, section J, which deals with commercial buildings, that was more or less rewritten. So there's a lot of change. Section J deals with the energy provisions of a building. So there was some really big changes there, which meant the introduction of a code called ASNZS 4214, which deals with thermal bridging. And thermal bridging is just areas of the wall or the ceiling or the floor that are uninsulated, where bridges. A bridge is a place where heat can be lost. Okay. Right. It doesn't deal with classes 1 and 2. So individual dwellings and multi-story residential buildings, but all the other classes it does. So that was a huge change for NCC 2019. More recently, NCC 2022. Number of changes, but a significant one was the introduction of a breathable wrap, like that Brent just spoke about. So breathable wraps are now required for class. I think, is it class 1, Brent?
Yeah, correct. Class 1 in residential space. Yep.
Yep. For climate zones 6, 7, and 8. Okay, so the colder climates for new residential class 1 buildings, they need to put a breathable wrap in. So climate zones 6, 7, 8, typically colder climates, like Brent said, Canberra, Melbourne, Tasmania, western parts of New South Wales. Those areas are typically, again, areas where you're likely to get mold and mildew build up in buildings. It's really important you allow that vapor to escape.
Kingspan does a whole lot of environment, not just insulation. You guys recently partnered with Seabin, wasn't it? Sydney Harbour.
Yeah.
which I noticed that happens on a regular basis. I don't know why people want to throw shopping trolleys into the harbour. I'll never understand. Can you guys tell me more about that and other similar, programs you may be doing?
Yeah, for sure. Yep. So Kingspan's got a global sustainability strategy. So we're calling it Planet Passionate. So globally, Planet Passionate is about, just there's looking after the environment, becoming more circular. Effectively, there's 4 key areas of carbon, waste, water, and energy, and we've got targets globally to achieve certain targets by 2030 as part of the Paris Agreement that the government's hitting. I mean, buildings are typically energy sucking beasts, and they use a lot of resources, and we're trying to do our part of being a buildings material manufacturer and supplier. And then we need to ensure that we need to ensure that we're part of that as well. So there's a lot of work going on behind the scenes, but to make our product net carbon zero, to make our manufacturing facilities greener and more sustainable. Like Brent said earlier, our factory in Melbourne was the first factory that got a 6-star Green Star rated. It's got PV cells on the roof. We harvest water. We recycle material where we can. We've almost gone all green, all electric. Got rid of the majority of our use of gas.
Wow.
And that'll continue. And where we are, it's all green gas. But aside from that, we do little initiatives. One of them was a thing called Seabin. So Seabin's a device that sits in harbours and oceanways and rivers and so on, and it just collects floating debris that's in a river. And it's a device. We've got a few of them in Sydney Harbour, and we sponsored one of them. We're sponsoring a number of them. There's one in California. There's one in Asia, and these things all over the world. But we've taken pride in partnering with people that are trying to achieve really cool things, like clean up the environments, like lowering carbon. We're putting some, we need more bees, for example, in the environment to pollinate. So we've got beehives at the factory now. We've got EPDs that have just been released of our products, which is an environmental product declaration. So we're very open around our carbon footprint, and what we claim is actually real, and it's not pretend. So we get independent organizations to prepare reports and so on that enable us to declare our place in the world. So EPDs do that for energy assessors to enable them to assess our products from a green point of view, because the green requirements and the green accreditation is ramping up significantly. So we're working closely with people like, the Green Building Council, for example, and aligning with trying to hit their targets, and that we can assist them in that regard with other large building material suppliers who are quite serious about this space.
So you guys do a fair bit when it comes to reducing your carbon
footprint. Yeah, carbon footprint's it's a big thing. For example, we're trying to source our materials from more locally instead of overseas. So, for example, our raw materials. Oops, stop that. Our raw materials, largely, not all things are made in Australia. So we need to source materials from overseas. And if we can source them locally, there's less use of ships and planes and boats and trucks and so on. So our carbon footprint continually reduces. It's a good system to measure your footprint such that once you've measured it, then you can improve on it. If you don't measure it in the first place, you've got no way to measure where you are in the world. So once you get a number, they show you how you calculate your EPDs, and then we can improve on that going forward. And that's part of, again, the Green Building Council, where they're headed. So, for example, a 6-star rated building, which we are, won't always be a 6-star building if you don't improve. You need to continually improve.
I'm actually impressed you have your own bees. Are we the Kingspan range of honey?
Oh, yes, definitely. For every 10 square meters of insulation, you get a jar of honey.
I do like that. I was going to say,
Be good, wouldn't it?
Oh, yeah, it would be a winner And I do hear what you say with supply chains. Yeah, globalization's a great idea, except it hasn't helped the environment, has it? As you said rightly, ships, planes, trains, and automobiles whizzing around the world, not great for that carbon output, is it?
Mm.
What is the newest insulation technology that we're yet to see? I mean, is there something that's coming out that you can tell us that, or some new technology, some new, some new material, some new idea that we are soon to see, or that may well become commonplace?
I could say, look, this is always a moving space. So the new technology, where it'll go, is where the National Construction Code is headed. Okay, so the code, like I said, 20 years ago, we didn't have to put insulation in buildings. There was no energy provisions at all for buildings, or if there were, that was tiny. This is not going backwards. This is only going forwards. So the technology will come with improved insulation materials. So in other words, what we're going to see is really thin materials with really high R values that are really green, that are really fire compliant. Okay. So we'll probably move away from products that are derived from high carbon based material, okay, that are highly resistant to heat and don't burn. That's a holy grail. Then that are also acoustic. Okay, so we're talking thermal insulation. Quite often, architects, engineers are saying, "Oh, that's a really, really good product." The cool therm, which is a really good product, has a very high R value for the thickness you're getting. So you get typically you get R1 for every 25 mil, 50 mil, you get R2 and so on. So for the thickness, you're getting a very high R value, but you're not getting much acoustic value. So they say, well, I need another acoustic product to supplement the thermal insulation. So for that thickness, there's always trade-offs. So again, your question around technology and what's coming out, that's where product will go. It'll go low carbon, low VAC, high R value, highly compliant around those three areas: green, thermal, and fire.
Okay, that's interesting. And interesting you threw in acoustic as well, which is something that we really haven't spoken about, have we?
No, it's another. There's
another podcast, mate.
It's another podcast, and it's people don't want noise, right? They want to live in buildings that are quiet. Yeah. And if you could have the garbage truck going up your street, or you've got it living on a highway, or you've got a construction site next door, no one wants to hear that.
Particularly when the houses are getting built closer and closer to each other, and there's more medium density construction going on as well. Everyone seems to be living a lot closer to each other. So for sure, the acoustic side of things is going to be very important moving forward.
Yeah.
Very, very interesting. Stuart Brain and Brent Levy from Kingspan. Thank you very much for that. Fascinating and really, really interesting. Who knew that insulation could be so fascinating? Thank you very much for that.
Thank you for having us.
Thanks for having us. It's been a pleasure. Hope everyone enjoyed the discussion.
I'm sure they will. You've been listening to Talking Architecture and Design. Until next time, goodbye. This has been Branko Militic, and you've been listening to Australia's most popular building and construction podcast, Talking Architecture and Design, brought to you from the Architecture and Design Network. Thank you once again to today's guests, Stuart Brain, the National Specification Manager for Kingspan Insulation, and Brent Livy, the National Residential Sales Manager for Kingspan Insulation. If you want more information, go to www.kingspaninsulation.com.au. And if you want to know more about architecture and design and our podcasts and our magazines, you can head over to architectureanddesign.com.au for all the latest news, views, projects, people, and much, much more. See you next time.